Transform video, and it's to deal with. Let me change it black to black. It's to deal with dy over dx. Okay, now I'm going to just rewrite this and I'm just going to call it, sorry, that's t. That's t. Okay, I'm just going to rewrite it and call it, okay, like that. It's just easier. Okay, so we're Laplacing this. Okay, this is the annoying one. Okay, so this one starts off with infinity sign e minus st multiplied by the differential sign ft, yeah, dt. Okay, now again what we're going to say is we're going to set the limit. We're going to call it a, goes all the way to infinity. You can call it whatever, you can call it k, you can call it z, you can call it n, it doesn't really matter. So we're going to replace that with a 0 e minus st multiplied by f of dash t dt. What can you notice? This has a t, this function has a t, and this function has a t. So what we're going to do, we're going to have the lovely integration by parts. Okay? And I'm just going to get to it, to be fair. This time, in the last one I did it, I integrated the e. Okay, now this time I'm not going to integrate the e. Why? Because if I differentiate f of t, I don't know, I can't really differentiate f of t. I'll just get f double t so I'll get, if I differentiate f of t, if I differentiate this, I'll get this. That does not solve anything, that just makes life harder. Okay, instead, if I integrate this, I'll get f dash t. Now that doesn't help either, but it's a lot easier for me to deal with this than it is to deal with the double differentiation version. And if I differentiate e minus st, well, I'm just going to get minus e minus st. Okay? Alright, so what I end up getting, and again, like seriously, for this part, if you really want to understand what's going on here, I suggest you go watch videos on integration by parts. It's not that complicated. I just don't. I actually like it, but it's just annoying me for my own reasons. So I'm definitely not making a video on it because it's vexing my life out. Okay, never mind. Okay. Party pooper and that. Alright, so where are we now? We are, okay, so now, remember the rule was uv minus u dash v, okay? So my u, which is the differentiation ones, and the I is the v, so what I'm gonna get is e minus st f dash t zero plus I feel like I've done something wrong. No, that's right. Okay. Okay, so if I then plug in everything, so the first bracket here will be e minus s a bracket f of a, close the bracket, minus e minus s0 f of 0 plus, okay, so what I'm going to do is, well, s is just a constant, so I'm going to bring it back out. Okay, sorry, I did do a mistake. I did do a mistake. That's minus EST. That's minus EST. That's minus. And then, okay, yeah, sorry. So when you differentiate this, E minus ST, that becomes minus S, E minus ST. And then the equation in itself has a negative. Okay, so when I pull, so that's the equation correctly. So when I pull negative S out, it makes that positive S. I knew I did something wrong. And then I'm left with infinity, 0, E minus ST, FT dt. Now, over here, what I'm going to get is, oh well, again, this is going to outdo the whole thing, and it's going to just give me 0. Okay? Minus, well, this over here, e to the minus s of 0, that's 1. Okay, that's going to give me 1. 1 times f of 0. I don't know what f of 0 is. Okay? Plus s. Okay? Now, over here, this is lovely. Okay? At the very start of the whole entire thing, oh, I need space for this. Alright, and if you notice something, alright, this part here, when it pops up, okay, we always leave it with the infinity. We always try to get it to be e minus st ft. If you remember, the Laplace transform, okay, is a function. If you take the Laplace of a function of t, okay, you get am I correct or am I wrong? I'm correct. I'm obviously correct. I'm always correct. Okay, and when you have something like this, this is its general rule. This is not me doing anything. This is the general rule for it. When you have something like this, you get LS. Okay, that's just the rule for it. Okay, so really, this part here is f of s. Okay, so all in all, what the answer I get, I'm just going to rearrange it slightly, is s f of s minus f0. Okay, and that's it. That's it. Anytime you have a differential sign, regardless if it's dy or d over dt, dx over these three k or whatever these letters are, okay, your answer is always going to be this, okay? And as we said, the Laplace transform transforms your equation from a function of t to a function of s, regardless. So you're always going to end up with this, okay? Even if the t is a k or an l, as long as it represents time, it will always come out as s, okay? Space. And hence what you get here, well, what we did here, over here, if you notice, even the last part of the video, what I had was, I tried my best to get it to be E minus ST, alright? And that's what I did here again, I tried my best to get it to be E minus ST, but I couldn't get rid of the F over T, FT, because you just can't pull it out, that's part of it. I can pull out the S, because that's a constant. This is not a constant, that's a variable, it's a function of T, and T is the variable in the equation, I can't pull it out. In this specific case here, well, that's identical to this. So we've done that now. So yeah, that's so if you have a question where the question is dy dx t plus t equals 4, well, the solution to that is s do I write back? No. It's s multiplied by fs, okay, minus f of 0, okay, I'm just going to put in the brackets so we can see what we're doing. Plus 1 over s squared equals 1 over, 4 over s. Okay? You have successfully Laplaced this. I wasn't meant to do it like that. Laplace this equation. Okay? Now, if you're all feeling happy and you're ready to tackle it, tackle this. Okay, I hate my life because of this equation. This is why, this equation here is literally why I'm not going to go through integration by parts. I cannot be asked anymore. It's depressing. Okay, well, this is it. You can tackle that question now. Boom, shaki, wow, wow. So my baby says, bow, wow, wow. How do I get this to stop again?